Hey, really quick lesson here. We're going to go through two reactions, our first two reactions of this unit, and it's combustion and then hydrogenation, which is a type of addition reaction. So right now, all we've learned about is hydrocarbons. So these are two reactions that can happen just straight to hydrocarbons. And then as we go on, we're going to take a look at reactions that go outside of hydrocarbons for reactants. But for right now, our reactants are hydrocarbons. So combustion. We already know all about combustion. Yeah, it is when I take some kind of fuel, I react it with oxygen, then I get oxide products of the elements that were in the fuel. So, because we already know about combustion, we can actually just kind of do this quite easily. The big reactant you're looking for here, and this is the only reaction you'll learn about that has this reactant, is oxygen. So as soon as you see O2, you know that you're dealing with a combustion reaction. You don't have to think anymore about it. And you're going to make the oxides of the elements that are in the fuel. For a hydrocarbon, that's really simple. I have carbon and I have hydrogen in that fuel. So I'm going to get carbon dioxide and water vapor, H2O gas, as products for this. So if I have pentane and oxygen, well, then I get carbon dioxide and water as products. So I don't even know what else to say about this. You already know about combustion. You're just doing it here. I ended up drawing the structure for carbon dioxide and for water. The coefficients aren't as important in this as just kind of the structures of the things I'm dealing with. So oxygen has a double bond. And then I have CO2, which has two double bonds going from carbon to the oxygens. And then, of course, water with that V-shaped structure there. The other type of reaction we're going to learn about is called hydrogenation. This is a type of addition, and addition are reactions that occur to unsaturated hydrocarbons. So hydrocarbons that have a double or a triple bond. And what is happening in addition is that atoms are adding to the carbons that are part of the double or triple bond. So the double or triple bond is breaking in order to form bonds with whatever I'm adding to it in the reaction. In hydrogenation, I'm adding, surprise, surprise, hydrogen to the unsaturated hydrocarbon, and as a result, I make it more saturated. So if I have an alkyne and hydrogen, and it's a limited amount of hydrogen, then I end up with just an alkene, so a double bond. And if I had an alkene and hydrogen, well, then I would end up getting an alkane because I'm breaking the double bond in order to make more carbon-hydrogen bonds. So here's an example. If I had 4-methyl pent-2-ine and then I added hydrogen, well, one hydrogen would add to this carbon and one hydrogen would add to this carbon. So this would break and I would end up now with a double bond. And the carbon-carbon bond breaking allows this to form a carbon-hydrogen bond and this to form a carbon-hydrogen bond. And I end up with 4-methyl pent-2-ene. Got to be really careful with numbering and stuff here because it can actually change how numbering happens. Now, this is where hydrogen was limited. If I had hydrogen and it said excess with it, then it would be turning this alkyne all the way into an alkane. So it would actually react with this once and then again in order to make this become a single bond. And in this case, it would become 2-methyl pentane as a product. It's kind of interesting to point out. So if it says excess hydrogen, then I actually react an alkyne all the way to be single bonded alkanes instead. Here's another one, 4-methyl pent-2-ene and hydrogen. So here it's an alkene that I'm dealing with. I'm adding hydrogen and the hydrogen again attaches to the carbon that had the double bonds. So then I end up with 2-methyl pentane as a product because I've added a hydrogen here and a hydrogen here by getting rid of my double bond right here. Let's try another couple of examples just to see if we have understanding of this. So this is not in your workbook, right? We're making this up on the fly, but I think it's important for you to see kind of, let's say, two reactions with the same compound, same hydrocarbon. So let's say we had something like CH3 to CH to double bond to CH to CH2 to CH3. I want to change this slightly. We're going to go ahead and put a methyl group right here. Okay, so this would be called 4-methyl pent-2-ene, as it is right now. So let's say I was taking 4-methyl pent-2-ene and I was reacting it with oxygen, O2 gas. What would be the products that I get? And the answer should be that this is combustion because I have oxygen. So I'm going to get carbon dioxide, CO2, and H2O. Now I'm not going to go through and balance this. I don't really care about that. I'm focusing right now on which products I'm getting. So I'm doing an unbalanced reaction, but showing the structure of the products. All right, now let's change this and go with this reaction with the same exact compound. So I'm again drawing out my 4-methyl pent-2-ene, but now we're gonna react it instead with hydrogen, right? So different elements, and I realized that I screwed up that number right there. So we're going to react that with H2. And my question for you would be, well, what product would we end up getting here? And the hydrogen would add both to this carbon and this carbon, right? The double bond would break. So I would end up with CH3, bond CH2, bond CH2, bond CH, and then to CH3. And my methyl group would be right here. So now what's interesting is my numbering for this ends up changing. And what I end up with for a product is 2-methyl pentane. So because I don't have that double bond anymore, this now becomes carbon 1 and 2. Instead of it going left to right, the numbering is now right to left in order for this to work. Anyways, so kind of this would be my hydrogenation reaction, obviously, hydrogenation. Well, this one right here was my combustion reaction. Just kind of cleaning this up to make sure that I have everything here that I should. This was hydrogen that I was reacting with. And this was, again, the same compound I had before, which is 4-methyl pent-2-ene. Yeah, great. Okay, so that is combustion and hydrogenation, okay, of hydrocarbons. Your first 2 reactions in this unit.